There was a time when electrical splices were not permitted inside a panel enclosure, the primary concern being the potential hazard they posed. A poorly executed or unsecured splice could loosen over time, increasing the risk of a short circuit or even an electrical fire. Prior to 1996, the National Electrical Code, or NEC, reflected this concern and generally prohibited splices within panel enclosures. However, the NEC underwent revisions in 1996 that significantly altered this stance. The revised code permitted splices inside panel enclosures, provided they adhered to specific requirements ensuring safety and reliability. The fundamental condition for allowing splices was that they must be properly made and adequately insulated. This change recognized that with advancements in wiring methods and connector technology, splices could be executed safely and reliably within panel enclosures. Despite this change, some individuals continue to believe that splices are not permitted in panel enclosures. This misconception can stem from several factors. Firstly, the NEC does not explicitly state in a single, easily quotable sentence that splices are allowed. The permission is implied through sections that discuss acceptable wiring methods and enclosure requirements. This implicit allowance can lead to confusion, particularly for those less familiar with navigating the complex language of the NEC. Secondly, awareness of the 1996 code revision may not be universal. Individuals who learned electrical work prior to 1996 may still operate under the older regulations unless they have actively kept up with code updates. Furthermore, some may have heard that splices are not allowed and never questioned the statement or researched the current code. It is crucial to emphasize that the allowance of splices inside panel enclosures is conditional. They are only permitted if they meet rigorous standards for workmanship and insulation. The NEC outlines specific requirements for wire connectors used in splices. Firstly, the connectors must be listed for the purpose, meaning they have been tested and certified by a recognized testing laboratory such as Underwriters Laboratories, or all, to meet specific safety and performance standards. Secondly, the connectors must be appropriate for the size and type of wire being spliced. Using an undersized connector can result in a loose connection, overheating, and potential failure. Thirdly, the connectors must be installed according to the manufacturer's instructions. Proper installation ensures a secure and reliable connection. In addition to using appropriate connectors, proper insulation is critical for splice safety. Firstly, all splices must be insulated with materials rated for the voltage and temperature of the circuit. Electrical tape is a common insulating material, but it must be applied correctly, using overlapping layers to ensure complete coverage. Secondly, heat shrink tubing provides a more robust and reliable insulation method. When heated, the tubing shrinks tightly around the splice, providing a secure and waterproof seal. Thirdly, pre-insulated connectors offer a convenient and reliable solution. These connectors have an integrated insulation sleeve that eliminates the need for separate taping or heat shrinking. When working with splices inside panel enclosures, it is essential to consider several factors. Firstly, the available space within the enclosure must be sufficient to accommodate the splices without overcrowding. Overcrowding can make it difficult to access and work on the panel's components, and it can also increase the risk of damage to the wiring. Secondly, the splices must be neatly organized and secured within the enclosure. This can be achieved using wire ties or other securing methods. Thirdly, the splices must be accessible for inspection and maintenance. They should not be buried behind other components or made inaccessible. The NEC provides additional guidance on the installation of splices in panel enclosures. Firstly, Section 314.16 regarding the number of conductors in outlet, device, and junction boxes is relevant. Although panel enclosures are not technically junction boxes, the principles of not overcrowding conductors apply. Secondly, Section 110.12 emphasizes neat and workmanlike manner of installation. This general requirement applies to all electrical work, including splices in panel enclosures. It mandates that installations be performed in a neat and professional manner, ensuring safety and reliability. Thirdly, local amendments to the NEC may exist. Local jurisdictions often adopt the NEC with amendments to address specific local conditions or concerns. It is crucial to be aware of any local amendments that may affect the installation of splices in panel enclosures. When in doubt about whether a splice is permitted or how to properly install it, consulting with a qualified electrician is always recommended. Qualified electricians possess the knowledge, skills, and experience to ensure that electrical work is performed safely and in accordance with the NEC and local codes. They can assess the specific situation, determine the appropriate wiring methods and materials, and perform the work in a safe and professional manner. Attempting electrical work without the necessary qualifications can be dangerous and may violate local codes. The potential consequences of improper electrical work include electric shock, fire, and property damage. The key takeaways are: firstly, prior to 1996, splices were generally prohibited in side panel enclosures due to safety concerns. Secondly, the 1996 NEC revision permitted splices in side panel enclosures, provided they are properly made and insulated. Thirdly, the NEC does not explicitly state that splices are allowed, which can lead to confusion. Fourthly, misconceptions about the allowance of splices may persist due to lack of awareness of code changes or misinterpretations of the code. Fifthly, splices must be made with listed connectors appropriate for the wire size and type. Sixthly, splices must be properly insulated with electrical tape, heat shrink tubing, or pre-insulated connectors. Seventhly, splices must be neatly organized, secured, and accessible within the enclosure. Eighthly, the NEC provides additional guidance on conductor fill, neat workmanship, and other relevant factors. Ninthly, local amendments to the NEC may affect the installation of splices. And tenthly, consulting with a qualified electrician is recommended when in doubt about splice installation. In summary, while there was a time when splices were not allowed in side panel enclosures, the current NEC permits them under specific conditions. Understanding these conditions and adhering to proper installation practices is crucial for ensuring electrical safety and code compliance. It is also important to stay updated on code revisions and consult with qualified electricians when necessary. The NEC is a comprehensive document, and interpreting its provisions can be challenging. However, it is essential to understand and comply with the code to ensure the safety of electrical installations. Electrical work should only be performed by qualified individuals who possess the necessary knowledge and skills. Attempting electrical work without proper training can be dangerous and may have serious consequences. Furthermore, regular inspections and maintenance of electrical systems are essential for identifying and addressing potential hazards before they lead to accidents. Electrical panels should be inspected periodically to ensure that all connections are tight, that there are no signs of damage or overheating, and that all components are functioning properly. If any issues are identified, they should be addressed promptly by a qualified electrician. By following these guidelines, it is possible to ensure the safety and reliability of electrical systems. In addition to the topics already discussed, it is important to consider the impact of technological advancements on electrical splicing practices. Firstly, the development of new and improved wire connectors has significantly enhanced the reliability and safety of splices. These connectors are designed to provide a secure and long-lasting connection, minimizing the risk of loosening or failure. Secondly, advancements in insulation materials have also contributed to improved splice safety. Modern electrical tapes and heat shrink tubing offer superior insulation properties, protecting against electrical shock and preventing short circuits. Thirdly, the increasing use of pre-insulated connectors has simplified the splicing process and reduced the potential for errors. These connectors eliminate the need for separate taping or heat shrinking, ensuring a consistent and reliable insulation. Furthermore, the development of online resources and training programs has made it easier for electricians to stay up to date on the latest code requirements and best practices for electrical splicing. These resources provide valuable information and guidance, helping electricians to perform their work safely and effectively. Firstly, it's also worth briefly mentioning the role of arc fault circuit interrupters, or FSIs, and ground fault circuit interrupters, or GFCIs, in enhancing electrical safety in general. While not directly related to splicing, these devices provide an additional layer of protection against electrical hazards, such as arc faults and ground faults, which can be caused by faulty wiring or damaged insulation. Secondly, it's vital to reiterate the importance of regular electrical inspections. Homeowners should have their electrical systems inspected periodically by a qualified electrician to identify any potential problems before they become serious hazards. These inspections can help to detect loose connections, damaged wiring, and other issues that could lead to electrical fires or shocks. In conclusion, electrical splicing practices have evolved significantly over time thanks to advancements in technology and changes in the NEC. While splices were once prohibited inside panel enclosures, they are now permitted under specific conditions that ensure safety and reliability. By understanding these conditions, using appropriate materials and techniques, and staying up to date on code requirements, electricians can perform electrical splicing work safely and effectively. And finally, remember that when in doubt, it is always best to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the NEC and local codes.